The position vectors of the points A and B are given by A equals 2i minus 2j plus k, and B equals I minus 4j plus 8k, respectively. Find the angle between the vectors A and B. Write down the vector AB. Find the vector equation of the line AB. The vector equation of the line L is given by R equals minus I minus 4j minus 2k, plus mu I plus j minus k. Show that the lines AB and L intersect and find the position vector of the point of intersection. Okay, so I've got the question in summary form here. So let's have a look at it then. The angle between the vector, first of all. Here we use the dot product. So A dot B is equal to modulus of A times modulus of B times the cosine of the angle between them. So here, if we do A dot B, then we've got so we've got 2i, let's write it out fully, minus 2j plus k, dot product with I minus 4j plus 8k is equal to, now we need the modulus of A, the size of the vector then, so we square, square and add them up and square root the sum, don't we, using Pythag. 4 plus 4 plus 1. So that's that one, times the square root of, and this one is 1, plus 4 squared minus 4 squared is 16, 8 squared is 64, isn't it? So that times the cosine of the angle theta. So that tells us then that cosine theta is equal to 2 1s are 2, minus 2 times minus 4 is plus 8, 1 times 8 is 8. Now I'm going to move these two numbers down below and underneath the other side. Root 9 is 3, and this is 64, 81. Square root of 81 is 9. So we can put it like that. 16 plus 2 is 18 over 27, which is 2 over 3. So we just need to do shift cos, and we'll be in degrees mode. I think is probably best for this. So let's go to degrees number 3, and it's shift cos 2/3, isn't it? So shift cos of 2 divided by 3 equals 48.19 degrees. So let's do it to 2dp. Theta is equal to 48.19 degrees. So there's the angle between the vectors A and B. Write down AB. So this is part B now. Part 1. So A to B, well that's just going to be B minus A, isn't it? So there's B there, so it's what I minus 4j plus 8k, B minus the A vector, isn't it? 2i minus 2j plus k. Let's work that out then. Fairly straightforward to do. But we've got to be careful with this minus as it goes all the way through, doesn't it? So 1 minus 2 is minus 1, I. Minus 4 minus minus is plus, plus 2 is minus 2j. And 8 minus 1 is 7. So there's the vector AB. So we've done that. Part 2, find the vector equation of the line AB. So line AB, part 2. We'll have the vector R, the position of the line vector, is equal to, let's write down the vector A, first of all, 2i minus 2j plus k. So there's A, plus lambda times the directional vector AB, isn't it? Which is this one here. Minus I minus 2j plus 7k. There we go. So there's part 2 completed, the vector equation of the line AB. Line L is this. Show that these lines intersect. So let's just write this equation down from above then, here. So this was R1, isn't it? And R2, which is the line in question in the question. It's just to categorize them separately. Minus I, minus 4j, minus 2k plus mu I plus j minus k. So there's our two lines. Show that these two lines intersect and find the position vector of the point of intersection. So here the lines intersect provided that the x, y and z components of the vector will equal one another. So let's work out and see what values of lambda and mu we need. So 2 minus lambda is the I component for the first line, must equal minus 1 plus mu. That's number 1. For the j, we've got minus 2j minus 2 lambda must equal minus 4j plus mu. That's equation 2 for the j component. And then as far as the k component is concerned, 1 plus 7 lambda must equal minus 2 minus mu. So there we go, there's number 3. So let's add 2 and 3 and then the mu's will disappear and we can find lambda. So 2 plus 3, that's the easiest thing to do, gives, so here what have we got then? We're going to have 5 lambda. We don't want to write the j vector down, do we? So let me just get rid of that. It's just a number we need. So minus 2 plus 1 is minus 1. 5 lambda is equal to minus 6 when we add these, and these will cancel, that's why we're doing it. So 5 lambda then, leave that as is, move this to plus 1, minus 6 plus 1 is minus 5. So that tells us that lambda is equal to minus 1. So let's do 2, let's do 1 rather, which is slightly easier to get. Well, let's do 2 then. By 2, minus 2 lambda, minus 2 times lambda, so minus 2 times minus 1 is plus 2, equals minus 4 plus mu. So that tells us that mu, reading from right to left, this is 0, move the minus 4 to be over with it, plus 4, and read from right to left and we get mu equals 4. So that's what we get from 2 and 3. Equation 1 now gives, so let's see if it's compatible with the first equation. So to see if there's a genuine point of intersection in the 3 dimensions. So 2 minus lambda, 2 minus minus 1 is equal to, and then it will be minus 1 plus 4. 3 on this side, 2 minus minus is 2 plus 1 is 3, minus 1 plus 4 is also 3. So yes, yes, so lines intersect. And we can now write down the vector where they intersect at. So if we put lambda equals minus 1 in the first line, we're going to have 2 minus lambda, which is minus 1. So that's the first component. Then the y component is minus 2. Minus 2 lambda, which is going to be a plus 2. And then the z is 1. Plus 7 lambda, which is minus 7. i.e. 3, 0 and minus 6 is the position vector, which we ought to write as 3i minus 6k.